today's TP story. What could go wrong?
The threats to the roof of the world. The third pole, which is centered on the Tibetan Plateau, is known for its marvelous mountains, glassy lakes, mind-blowing starlit sky, and distinctive cultures. As the roof of the world, it possesses a charm irresistible to adventurous hearts and curious minds worldwide. However, its breathtaking beauty and global fame come at a price. Strong tectonic activity, complex geomorphology, a changing climate, and more human presence at the third pole have also made the region extremely vulnerable to natural hazards. Earthquakes, debris flows, glacial lake outbursts, torrential floods, landslides, avalanches, snowstorms, and drought. Almost all the natural hazards one can name have occurred at the third pole.
The uplift of third pole makes tectonic activity extremely prevalent in the region, which gives rise to earthquakes along the fault zones. Uneven distribution of water vapor at the third pole as a result of its climate patterns can trigger large-scale floods and droughts at the same time. The steep slope of third pole mountains can also easily turn glacial melting into glacial lake outbursts and debris flows, and turn torrential rain into landslides. Engineering projects can also destabilize the already fragile balance at the third pole.
Climate change is also not helping the situation. The third pole is getting warmer and generally moister, which enhances hydrological cycling in the region and makes water and ice-related disasters more likely. In the future, we expect hazards to occur more often, in more forms and have greater chain effects at the third pole. The growing population and economy are also adding to the elevated risk of disasters by altering exposure and vulnerability.
To fulfill its commitment to local communities, TPE has given priority to hazard-related scientific services.
The water cycle must be traced in 3 dimensions, as liquid water, ice and water vapor, on the ground and in the air, and changes monitored. Water isotopes high up or in the air, a previously unrecorded component on the continuous basis, is now being traced closely at the third pole. With in situ continuing measurements at stations and tethered balloons intermittently that can soar above 7,003 meters.
TPE has also set up ice collapse monitoring stations following massive ice collapses that occurred in the western and southeastern third pole areas over the last several years. The early warning system set up by TPE scientists in 2019 has since sounded alerts for Sadongpu ice collapses.
Future third pole research should prioritize such topics as changes in the factors causing hazards and regional patterns related to hazard development, the dynamic processes and mechanisms of natural calamities, the evolution of catastrophes caused by the coupling of climate change and earthquakes, the methodology of assessment and management of disaster risk, and monitoring and prevention technology suitable for alpine environments.
Amid all these uncertainties, however, one thing is certain: TPE scientists will continue to study the causes and development of natural hazards, with a view to minimizing local and global losses.
Stay tuned for more TP stories at www.tpe.ac.cn.